Hello guys, hope you're doing well. And as always, if you are new to my channel, I would humbly request you to subscribe to my channel so that you should be able to see all the latest engineering videos. So today our topic is failure mode and effect analysis, which is called as FMEA. As far as this topic concerned, it is a very important reliability tool. Okay, so it is very critical. Okay, it's critical in a way. Why FME is critical? Because it depends upon four functions. The one function is knowledge based. The second is it's helpful in risk assessment. Again, this tool is helpful in the continuous improvement of your process, and again, it is very helpful uh, as a quality control tool. Okay, so this is very important. One of the most important advantages of FMEA that it basically helps you in all these four categories of your production are basically your process and basically also as far as design. What is FMEA? It is the analysis of potential failure. Potential meaning is a word which means future failures. Okay, potential, which means those failures that have not happened, but they could happen as a result of any consequences or any weaknesses in your process or in your design. Okay, so classification of failures by severity of the effects, how often they occur, and how easily they can be detected. Okay, this is very important because whenever failure is there, it is being graded by a factor of severity, whether there is the severity is low or it is very high. There is a lot of human lives being lost, and how easily they can be detected. Definition of controls to prevent the failures, and what do we need to do next. This is what happened if an accident has happened or a failure is there, some sort of a catastrophe has occurred. What can we do that it does not repeat? That is where FMEA is really comes into its own. The history of FMEA is very important. Okay. Originally, it was developed in the 1940s by the US military, utilized in the Apollo space program to minimize the failures of expensive prototypes. Ford formally brought it into its automotive industry in the 1970s after the Pinto thermal events. Okay. Benefits of FMEA. Again, the important benefits of FMEA are reduced costs, field failures, scrap. Again, this is reduction. It helps you prioritize risks what are more important than the others. And again, engineering and manufacturing knowledge base. So these are the benefits of the FMEA. It prevents other benefits of FMEA are it prevents failure before they happen, identifies critical aspects of design and processes, identify controls needed, identifies where to focus to bring on the change, bring on the improvement in your design or system, essential to quality improvement, and it is essential to quality. Types of FMEAs. There are mainly two types of FMEA, the design FMEA, which is called DFMEA, and the process FMEA, which is called PFMEA. You have other types of FMEA as well, the concept, the system, and services, but we'll be tackling these two, the design and the process. What makes an FMEA is basically the customer requirements. For example, you have got a QFD process being done, the quality function deployment, and there is customer requirements, custom grievances that needs to be incorporated into your design or your process. So you will do an FMEA. Or you have some experience or knowledge database that you can do for an improvement, or an accident may not happen, or some accident may have happened now, and the lessons learned, and you want to improve it. And again, if there's a product and there's a new model of a car coming, and you have some improvement to be done, so you will always doing FMEA on specific components of parts of your systems for improvement. Then where it all fits. The product cycle is a very basic product cycle. whenever you design something, you need to have some market requirements. Then you design it for the market requirements. You undergo the production of that component or system, and then you send it to the customer, and you want your customer to be happy. Product cycle. The big question is, again, this is your product cycle: customer requirement, design, production, satisfied customer. The big question is, what is important, and how are we ensuring it is right? So the answer for it: critical characteristics are output from the FMEA and input into the FMEA. What does it mean? That some component has failed and there is a production of that component being happening. So you cannot change the production. What you have to do is you have to bring changes in your design, and your design engineers and reliability engineers will work together to bring on the changes in your design, and those design changes will basically be sent to the production, where a new and updated PFMA is being developed to incorporate those design changes and improve your system, either product or services. That is the meaning of the big answer. So DFMEA stands for basically design failure mode effect analysis. What do they need? He's asking about the customers. What's critical for them? Their life is at stake. How to improve, safeguard their life. What do we know? What can go wrong in the future of your system? And what happens if it goes wrong? Which means what is the severity? Okay. So what have we learned out of it? How can we make it better? This is from the design and production process. The first one was from the customer point of view, and this is from the design and production. How can we make it better, and how can we reduce the cost? Okay. The same thing for PFEMA is, what do they need? What's critical? What do we know? These are the questions to be asked by the team to bring on the changes. What can go wrong? What happens? And from the production and satisfied customer point of view, the PFEMA and DFEMA, what have we learned out of it? How can we make it even better? And how can we reduce the cost? This is a generic form, a generic FMEA form for any failure mode effect analysis to be done by you. So any component, its functioning is being defined over here. How that component can fail, list all the potential failure modes. Then if it fails, what will be its potential effect of failure? Then if it fails, will that failure will be very severe, or its severity will be medium or low? Potential causes of mechanisms and failures. You have to tell that what could be the cause of that mechanism, or basically causes and mechanisms of failure. That what could be the potential causes of that system or the component could fail. And then you have to tell about the occurrences. If those components or systems malfunction, what will be their occurrence? Will their occurrence be very remote, very low, medium, or high? And how will they be detected? By means of the design controls. Okay, by those design controls which you have over here, and by virtue of which you can detect them for the failure. Okay, and then this RPN stands for is basically you have to multiply the severity, which is gauged on a factor of 1 to 10, occurrence gauged on a factor of 1 to 10, and detection gauged on a factor of 1 to 10. You multiply the three by 10 into 10, 10 maximum is 1000. Okay, so you're gauging them, and whatever values you received from your experience point of view or from the design engineering point of view, you will be put it over here, and you will multiply it with, and you'll get your RPN numbers, risk priority numbers. Once that is being done, now you have to sit back at the drawing board, and after reading all these FMEAs, you have to suggest recommended actions for all those failure modes. And basically, your main target is basically is to reduce this effect of severity. You also want to basically reduce the effect of occurrence, that happening is very low, and basically you have to suggest recommended actions. Then responsibility and target completion date to be taken. And in order to complete those recommended actions, actions you have taken is basically severity, occurrence, detection is being, you multiply them with new values of severity, occurrence, detection as a result of this recommended actions. You will have RPN numbers which will be comparatively lower than these RPN numbers, which means that you have optimized your component or your system or your process. Okay, so an example FMEA is given to us. Okay, so for this instead, we can what do is that I have basically uh, this FMEA form is basically giving you an example of a potential failure mode and effect analysis of a DFMEA being done. Okay, you can see all these things which needs to be written, and function is being defined over here. If you look at it, it's basically if you look at it, it's for the component. Sorry, it's for a component braking system. Okay, so if you look at it here, we can basically, this is for a component braking system, this FMEA. So for what will be the function, you can see vehicle should stop when the brakes are applied, a very genuine function. What will be the potential failure modes? It will be that the failure mode for a braking system is it does not stop. If the brake does not works and it does not stop, it means a crash. So you can say it's a total failure. Potential effects of the failure. What will be the effect of this failure? It is an accident. So an accident is an accident. We can grade it as 10. Very, very critical. We don't want an accident. Whether it's a small accident or a very big accident, we don't want it. We say severity is very high. So what will be the causes of that failure compared when you're watching this function? Vehicle should stop when brakes are applied. Causes of the failure could be brake fluid is low. Okay, so when the fluid is low, you apply the brake, the pressure is not being generated. Okay, your master cylinder is malfunctioning. Means your master cylinder is the seal is leaked, or basically there is some sort of a locking being there, or some component is broken, so it's malfunctioning. And again, you can have air in the hydraulic system. Okay, and apart from that, another causes of failure is introduction of water in the hydraulic system. The brake oil has some sort of contamination of a chemical or water. So these are the occurrences. There you can see by reading this, you can see this does not happens very frequently. So the occurrences could be graded as 4. Air in the hydraulic system is more common. You can say 5. A chemical or water contamination is 5. Okay. So now we go to the design controls, the current design controls. Okay, we see that we can see that with the reservoir level is low. Okay, so you can see the reservoir to see level of oil. You can see from your brake oil bottle that the reservoir bottle of reservoir level of oil is low. Okay, and its detection is basically 2. Okay, again, periodic checks should be done whether the brake oil is low, it's full, or braking are working properly. So you can, for checkups, you can take it to the mechanic. 4. Determine from the quality of oil. You use a very high grade quality oil. Don't use a low grade quality of oil. Okay, so its detection is 4. Determine the from the quality of oil. Again, this is what it is. For the again introduction of water in the hydraulic system. So for these current design controls, you can see to detect them in your system is very low. It's 2, 4, 4, 3. So now you have basically performed an initial FMEA of this braking system which has undergone a failure. Now your severity was 10, your occurrence was 4, your detection was 2. So when you multiply 42 is 80. This is your RPN number. Okay. Now you have to perform for this, you have to perform recommended actions. You can use an electrical sensor to indicate the level of oil instead of seeing it by normal eye or human error can be there. You can use an electrical sensor to indicate the level of oil. Some sort of a beeping bell should be there that the oil is low, or some sort of a light blinking in your speedometer dial or cluster. Periodic checkups improve the material of again for recommended actions. You can also say uh, you improve the material of your valves. If the valves are okay, they will not fail that easily. Then leakages will not be there. And along the walls, I will say seals also. And for the year in the determine the form of quality oil and determine from the quality of oil. For this, you have some special appendices made by Ford Motor Company. They can check it from there. Then once this has been done, you have to the design team has to take some recommend some actions taken, and after those actions taken, properly taken, it has to be checked, and you will see that there will be a significant reduction in this value of 80, and it is being done by the team that you want to reduce the severity. What recommendations you will do, because it is very high. Okay, these are comparatively not high, but this has to be done, and to be you have to really reduce it for the actions taken. When you reduce it, your severity will go down. Occurrence and reduction are not okay, then not much problem. So when low severity multiplied by occurrence and detection, you will get a an RPN value which is lower than the initial RPN value when the failure had happened. So this is how you basically perform an FMEA. Okay, so this is again, this is just a part one of this. I have also have developed, this is part two. You can read it from here. I'm sorry, it's slightly difficult to read, but if you concentrate, you can read it. Okay, so this is for the again for the brake failure. The brake pedal should be basically pressed. Okay, and hard to press the pedal. Okay, okay, so brake pedal should be performing as normal. Okay, what he's trying to say here. So these are all the causes of failure, current design controls, recommended actions. Which this will be quite helpful for you. Apart from that, I have another example of a steering subsystem. Okay, steering subsystem failure mode and effect analysis based in the category of DFMEA. If you read it, it will help you. The functions, failure modes given, effect of failure, severity, classes, causes of failure, occurrence, detection, RPN calculated, recommended action shown, action taken, and optimized value of RPN being obtained. So this is how you basically perform a failure mode effect analysis of your system. Thank you very much. I hope you would have understood FMEA, and I hope you have a very good day. Thanks.